if you're going to be writing any significant amount of JavaScript code, then you're going to be using arrays, right? But if you're going to be using arrays, chances are very often you're going to be creating arrays. That's why I want to talk about array creation. This is a topic that is pretty fundamental to how JavaScript works, because arrays are created all the time. We see that a lot in real-world applications. You see arrays being created all the time, and it's an important thing to understand. And in fact, I want to kind of just take a moment to really clarify what happens when an array is created in JavaScript, because too often I think tutorials and courses go too fast over the creation of arrays. So I want to just take a moment and take a closer look. So let's see, and let's start with this question. Okay, I want to start with this question. Is this an array? So what we have here is I am assigning to a variable called myArray, and I have something that, well, at first glance, actually, yeah, that looks like an array, right? Let me draw here. So why do we know this is an array? It's because, well, we actually see this thing here. We see the familiar square brackets. That gives us an answer. Yeah, this is an array. We have a list of items inside of a pair of square brackets. In fact, in this case, we see 4 numbers. Now, in whatever code I'm writing here, maybe I'm writing this because these 4 numbers are significant. Maybe they're my favorite numbers. I don't know. But for some reason, I want to keep track of 4 numbers. But I want to actually answer this question in a different way. I want to look at this and I want to say, actually, no, that is not an array. This is an array expression. Okay, so, well, you might say to me, well, hold on. Of course, yeah, technically, what we're looking at is an expression. It's an array expression. But why do I want to make this point that that's not the array? In fact, it's just an array expression. Well, because what we have in memory when we create an array, that's something different than what we have in the code. And the reason why I say that is because what we have in memory is a function of what is happening at a given moment in the code. Right? If you make a snapshot of your running program, as it's running, you can like freeze time, and if you could look inside of the memory, then you would see in memory an array, and it would have some items as values. That's a snapshot in time. But when you're looking at your code, you're not looking at a snapshot in time of when your code is running. Your code exists before it even runs at all. And I want to make that distinction because that's a mental model that really helps to understand what's happening, to be able to make the distinction between what you see written in the code, namely expressions, and what you see in memory, the actual array that exists while your code is running. And listen, I'll give you an example right away to show you why this is significant. So let's take a look at this. Suppose in my code I have a bunch of things going on, and I have at some point this array expression down here. So here I have basically, an array expression with 4 items, 3 of which, the first 3, notice this about the array, are just strings that I've provided right there, but the last one is a variable. So, if you look at the line just above, you can see what I'm doing here. I previously assigned a value to this variable that I called last word, and then in the expression here, I assigned that, I placed that in the last item of the array expression. And that's why it's important to make the distinction between what we see in the code and what ends up created in memory, because after this code runs, what's going to be in memory? Well, a new array will now exist, and that new array will have 4 items, and the last item will be the one I gave here, so it's going to be a string that says soda. But we don't know that until the code runs. In fact, last word, it could be that I'm assigning the string right there that you see, but it could be that last word is coming from somewhere else. It could be the result of a function call. It could be coming from someone calling our function. It could be a function argument. It could be the result of a calculation. Who knows? So as far as this expression is concerned, it doesn't know that yet. So this isn't the array that will be created in memory, because we don't know what the last item will be until it gets evaluated. So the array expression doesn't necessarily match what the array is in memory. That's the point I'm trying to make. In fact, you might think of the array expression as like a template. It's saying we're going to have these items, and the last item in this case is going to be an item that we'll find out what it is, but we're saying that it's going to go here. So that's why I kind of like to call these expressions, they're called array expressions, but you know what? Here I wrote an array expression. I'm going to actually add here array creation expression. That's what they really are. These are array creation expressions. Why do I really want to emphasize the creation? Because that's what they do. When an array expression gets evaluated, it creates a new array in memory. And in fact, so I think this is where it gets interesting. And this is where you really, this one point, if you remember one point from this video, it's this. Every time an array expression gets evaluated, a new array gets created. Okay, this is the take-home message. Now you might say, well, hold on, what do you mean every time? How does an array expression get evaluated more than once? In the example we saw, we're just creating an array once. How can that code run multiple times? Well, easily, if it's inside of a function, for example. It could also be inside of a loop. If it's inside of a for loop, then that array expression will in fact get evaluated every time. Let's take this. I just wrote down a quick function here as an example. Okay, so here's my function. I called it create array with name, and it does something very simple. It just has one line where it returns an array expression. It returns an array here where I have a string 1, a string 2, and then name. So it's like I'm creating an array that's always going to have the same first two items, but the last one is going to depend on, notice here, on the function argument. That's what's going in to that last item. And like any function, I can call this function, and like I am doing here in the next lines, I can call this function any number of times that I want, and I can call it with different parameters every time. So I call create array with name with the string 3 as the value here, and I'm going to get an array in memory now. The actual array that will exist is going to be an array that says 1, 2, 3. If I call this function again with another string like fizz, then I'm going to have an array that contains 1, 2, fizz. So you see what's happening here. I'm using this array expression to create a new array every time. In fact, a different array every time. Even if the values are all the same, it will still create a new array. I didn't show it here, but what if I called that again? What if I did this function call again a second time with the same string fizz? Will I get a new array that's different, or will I get the same array? I'm actually going to get a new array. Now the array will have the same items, but in memory, I'm actually going to have a fresh new array that will get created, because that's the rule. The take-home message, it's always true. An array expression, no matter where it is in the code, no matter how many times you run it, it's always going to be true that every time the array expression gets evaluated, it creates a new array in memory. So let's take it as a, well, let's kind of analyze this idea of an array expression, because it's an expression. And most JavaScript code is made up of expressions. So I like to look at expressions in detail by kind of asking this question. Let's say we have like this other piece of code where I have an array of fruits here. I like to think of the question, what are the inputs and outputs and the side effects of this expression? Because every expression has some inputs, some values that it's taking from elsewhere or from sub-expressions that are inside of it. And there's always a result of the expression. When any expression gets evaluated, it produces a result. And now often, not always, but often expressions have a side effect. Something else that happens, it affects what we have in memory, excuse me, in some other ways often. That's a side effect. Something that's not the inputs or the outputs, but some other effect. So what about this? I want to look at this example here. I kind of just pulled out just the expression, just the array expression. What are the inputs? Because we have 3 items here, there are actually 3 sub-expressions. Each of these is a sub-expression. So I like to think of them as inputs into the expression. The first 2 are simple strings. They're actually literal strings. That's what we call strings that are there, right there in the code. But the third one is a variable name. So we know that this variable name is going to be evaluated, and we're going to get, as a result of that expression, that sub-expression, we're going to get the value that's currently inside of this variable, which I called favorite fruit. That's important to note, that it's going to be the value that's in there at the moment when the array expression is evaluated. So it could be anything. It could be changing over time. Maybe you're assigning different things to that variable. But when the expression is evaluated, that's when it's going to grab the value that's there. So those are the inputs. 3 items in this expression, so 3 inputs basically. Now what about the outputs? Well, the outputs is like saying, what does this produce? And this produces, well, simply enough, we kind of already know this, it produces an array in memory, a new array specifically. So I actually want to just emphasize this. The output of this expression is a new array. It's always a new array because that's what an array expression does. That's why I like to call it an array creation expression. What about side effects? Side effects, well, there is a side effect here, and I've already mentioned it a few times. What's the side effect of this expression getting evaluated? When it gets evaluated, what really happens outside of just the inputs and the outputs? Well, the memory is affected. Something happens in memory. What happens? An array gets created. Yeah, that's it. I mean, it's a simple side effect and maybe an obvious one. But it is a side effect because it happens outside of the inputs and the outputs. The output actually is that very same array which just got created. But the side effect is that it gets created somewhere outside of the expression. In fact, here's a way to sum it up. Okay, let's do a recap. How is an array expression evaluated? In 3 points. We're going to cover it in 3 points. Number 1, all item expressions are evaluated first. In other words, we need to first know when this evaluation begins. We need to know what the items are going to be. What are we putting into the array? Clearly, we need to know that. So that's why first we are going to find out each of the items. And if any of the items are sub-expressions, then those sub-expressions get evaluated first. We need to find out the result of those sub-expressions to then be able to put the values into the new array that we're going to create in memory. Cool. Okay. Number 2, a new array is created in memory. This is what happens kind of behind the scenes, right? We don't see this creation happening, but the JavaScript engine is going to go into memory and it's going to allocate some new space in memory and it's going to place this array there. That's what happens in the second point. And point number 3, the expression result. What is the expression result going to be? It's going to be that newly created array. So in other words, I like to think about it like this. This element, this point really corresponds to the inputs. The creation in memory is actually the side effect. And then finally, point number 3, well, we're talking about the result of the array, so it's the output. I need to make a kind of a final point here, because we can't talk about this without mentioning equality and the equality operators that JavaScript uses. Because we're talking about the creation of new arrays. When I say that every time a new array is created, it means that this new array, it literally is a new structure in the memory, and it it doesn't equal, it's not identical to any other arrays that have been created. Now this is really how the equality operators work in JavaScript. When you're using an equality operator, you're really asking, is one array the very same array as another one? So it could be that you have two variables and they may actually refer to the same array. That's very possible. One array in memory, two variables that contain that same array. They contain references to that same array. So that's where the equality operator can be useful. It's when you're checking, I have one array, but my two variables or two expressions that I have, are they actually the same array? Do they both refer to the same thing? But that's why we have to be careful, because if we have two distinct arrays but which happen to have the same items inside, there's still two distinct arrays. It's very possible to have two arrays existing in memory at the same time, which they all have the same items in them. The values of the items of the array can be all identical, and yet the two arrays are distinct. So that's something to watch out for. Basically, here's the example that I want to use of, like, the most basic example of where if you don't take into account the fact that this is how the equality operators work, then you might find this to be surprising. You might find that this isn't what you would expect the operators to do. So I have two arrays that I'm creating, and I'm placing this first one into a variable A, and I'm placing the second one into variable B. But they are actually identical expressions. So I am going to be having two arrays in memory. Two arrays will be created, right? And just because of the fundamental principle that every single time I have an array expression getting evaluated, I am going to have a new array created in memory, a distinct new array being created. Okay, so that means that now, after running this, I have variable A that contains the first array, and I have variable B that contains the second array, and they just happen to have the same values in them. So now when we evaluate this expression, so this is a simple expression that is using the equality operator to determine if A and B are identical, or in other words, if they point to the same array, do they refer to the same array? And the answer, what will you get if you evaluate this expression? Does A and B, do they refer to the same array? No, they don't, because they are two distinct arrays. That's why this will evaluate to false. And that is why I include a whole slide about just this point. It's to say that you might expect that two identical arrays, like basically identical in terms of their values, would be equal based on the equality operator, but that's not what the equality operator does. It doesn't compare the items. In fact, the equality operators, and I mean both the this one, the double equals, and the so-called strict equality operator, the triple equals, both of them, they do not look into the array. They don't care what you have in your arrays. They just ask the question, am I looking at the same array? So if you take that into account, then that explains this behavior. That explains why we get false instead of true when we use the equality operator on these two. Okay, great. So I mean, this has been really a look at array creation, and I hope you found this concept useful. I find that this mental model helps me out. It's helped me out over the years so many times, just being able to conceptualize the difference between an array as it exists in memory and the expression that exists in your code. So my name is Marek. This is JavaScript with Marek. Go to javascriptwithmarek.com and subscribe to get more of my content. So with that, I'm going to see you in the next video.